All right, everyone. So let's go ahead and talk about tangent and cotangent graphs. All right, so let's go ahead and take some notes. Okay, so let's just remember that the tangent is the sine divided by the cosine. That's the y divided by the x, by the way, y coordinate divided by x coordinate. And so if we go around the unit circle and go ahead and divide all the y coordinates by the x coordinates, this is what we will get. So for example, at pi over 6, if we do the y coordinate divided by the x coordinate and then rationalize, we will get root 3 over 3. Alrighty, and so here's what that looks like if we go ahead and string those points together, like punch them out and string them together, right? We're gonna get these values, okay, that kind of look like almost like a cubic function, but there's a bunch of them. It goes on and on and on forever. And you can see, for example, at pi over 2, you see that infinity sign? That means it's undefined. That means there's an asymptote right there, okay? And so here's another look. Okay, kind of looks like this if you wanted to see it in degrees. Okay, every 180 degrees, there's an asymptote kind of starting at, if you will, positive 90 degrees on the positive side of the y-axis. Okay, so let's talk about some key features. All right, so please note, unlike the sine and the cosine, a tangent has one cycle every 180 degrees or every pi in radians. So some key features. So the domain is x such that x is not pi over 2 or 90 degrees plus 180 degrees or pi, okay, every pi. And the range, you can say it as interval notation or in fancy set notation. Okay, as far as a stretch, like is it more linear looking or is it super curvy when it makes that little turn? Okay, on this particular one, on just the parent tangent graph, there isn't a stretch. Okay, the frequency is 1. The midline is y equals 0, okay, kind of like where the middle of the graph is where it takes that turn. Okay, the decrease on this interval from 0 to 2 pi, there isn't any. And then as far as an increase, there's an increase from 0 to 90. And then again from 90 to 270, not inclusive. And then from 270 to 360, okay, if we're just looking at the interval from 0 to 2 pi or 0 to 360, those would be the places where we'd see it increasing. Okay, so let's take another look, or look next rather, at the cotangent. All right, so for a cotangent, okay, that's the x divided by the y coordinates all the way around the unit circle, and or the cosine divided by the sine. Okay, and so if we go ahead and evaluate all those values, I found just a couple for you there in the first quadrant. If you take a close look at that chart, okay, you will see, okay, that you get all these values and it looks very similar to the tangent, but you can see that it goes the other direction, right? Okay, so it looks like it's decreasing forever, okay, except for where the asymptotes are. And take a look at where the asymptotes are. They're not starting at pi over 2. There's one at 0, and then the next one is at pi, and the next one after that is at 2 pi, and so on and so forth. Here's another look for you. Okay, so again, just like the tangent, and unlike the sine and the cosine, a cotangent also has one cycle every 180 degrees, not every 360. Okay, here's another look with both the degrees and the radians. All right, and so let's talk about the key features for a cotangent. Okay, well, pretty similar to the tangent. Okay, except for the asymptotes are in different spots, right? So it's x such that x isn't pi over n. So every interval of pi, okay, for the standard cotangent. Okay, then our range, it goes on forever in both directions, up and down. There's no stretch. The frequency is 1. The midline is y equals 0. The decrease on this one is from 0, if we're just looking from 0 to 2 pi, right, is 0 to 180 and then 180 to 360, okay? And then for that, or you could put it in radians. And then as far as the increase, there isn't any, okay? These decrease always from left to right. Okay, so here goes our wee problem. Let's go ahead and see if we can figure this one out. Okay, so let's see. Let's see if we can sketch the graph of the cotangent just on the interval from negative pi over 2 to 3 pi over 2. So go ahead and pause it, give it a try. Perfect. And if you did it correctly, you should be getting this. Should look something like this. Okay, from negative pi over 2, negative 90 degrees to positive 270, okay, and or negative pi over 2 to 3 pi over 2. Okay, let's look at our UL finally. Okay, and so let's see if we can state the key features of the range for a cotangent, a standard cotangent, and then also write the intervals of increase and decrease on the interval from pi over 2 to 3 pi over 2. See if you can do that. So go ahead and pause it, give it a shot. Okay, and if you've done it correctly, I think you should get these answers. All right, everyone, good work. Let's go ahead and get to the practice. Bye.